20 ml of the 0.2 molar sodium hydroxide is added to 50 ml of the 0.2 molar acetic acid to give a solution, and we have to find out the pH of a solution. The dissociation constant of the acetic acid is given. So basically we are mixing the sodium hydroxide, which is the base, with the acetic acid, which is the weak electrolyte, and in this mixture we have to find out the pH. First let's find out how many moles of the sodium hydroxide are there. Okay, so we will find out the number of the moles of the NaOH and the number of the moles of the acetic acid in the given volume. The 70 ml is the total volume, 20 plus 50, 20 ml of sodium hydroxide plus 50 ml of this the acetic acid, so the total volume is 70 ml. So let's find out the number of the moles of the NaOH there and also the number of the moles of the acetic acid first. We know the concentration C is equal to the N by V, the number of the moles divided by the volume of the solution in the liters, or the number of the moles will be equal to concentration into volume of solution in the liters. So let's first find out the number of the moles of the sodium hydroxide. So we actually have here a sodium hydroxide, the concentration is 0.2, so therefore the N for the sodium hydroxide will be 0.2 times the volume here is 20 ml, which in liters is 20 by 1000, so that will be 0.02, and this will be 0.004. Now this is the number of the moles of the sodium hydroxide in the mixture. Now we also added the acetic acid, the CH3COH, so let's find out the number of the moles of the acetic acid in this 70 ml solution. So we have added acetic acid, which is actually having a 70 ml, 50 ml of the volume, and 0.2 molar is the concentration. 0.2 times 50 ml means 50 by 1000, that is the volume of the solution in liters. So this is 0, this will be 0.05 here, and this will be 0.01. Now the number of the moles of the sodium hydroxide is 0.004 and the acetic acid is 0.01. So we have more acetic acid and less number of moles of the the sodium hydroxide. So let's first find out how the acetic acid and the sodium hydroxide react, in what mole ratio. You can easily see that this will be the 1:1, because when you actually react the acetic acid with the sodium hydroxide, this is a reaction between an acid and a base, and what you will get a salt of the sodium acetate, this acetic acid CH3CONA, sodium salt of the acetic acid, and you will get the water. Now you can see that the molecules they react in 1:1 ratio, 1 mole of acetic acid with the 1 mole of the sodium hydroxide. Since we have a higher concentration of an acetic acid, which is actually 0.01, so this is more. 0.01 is the number of the moles of the acetic acid, and we only have 0.004, right? 0.004 moles of the sodium hydroxide, which means that the amount of the acetic acid here, sodium acetate here, the salt in the mixture, in this mixture you will get the salt, which will be again 0.004, right? Because this is what it is the limiting reagent here, and the 0.004 moles of the sodium hydroxide will produce the 0.004 moles of the sodium acetate. So you will also have some of the the excess acid, unreacted acetic acid there, and the left amount, the acid that is left in the reaction will be, the number of the moles will be, the number of the moles of the acetic acid that are left will be 0.01 minus, and how much of the acetic acid will react? Again the 0.04, right? 0.004, so it will be 0.004. Now this is the amount of the acetic acid which is left, right, as acid. It does not react with the sodium hydroxide because all the sodium hydroxide has consumed, right? Now you will have 0.01 minus 0.004, which will be 0.006, right? This will be the acetic acid left. So that means after you mix the 20 ml of the 0.2 molar NaOH with the 50 ml of 0.2 molar of acetic acid, at the end you will see you will have a acetic acid 0.006 moles, right? You will have a 0.006 moles of the acetic acid and 0.0044 moles of the sodium acetate. Now this, you can see, is actually a buffer solution. You have a weak acid and the salt of the same weak acid. Now this will be a buffer solution. Now this is a buffer solution, and we can find out the pH of any buffer solution by using that, Henderson equation. We all know that the Henderson equation is the pH is actually equal to, that is equal to the negative log of the K, negative log of the Ka plus the log concentration of the salt by the acid, right? Now since we calculated the concentration of the acid and the salt, now we can easily find out the pH also. So the dissociation constant is given 1.8, so this is minus log of the concentration of 1.8 into 10 power negative 5 here, plus it will be the concentration of the salt here is, which is 0.004 divided by the concentration of acetic acid, which is 0.006 here. Okay, so now you can first you can further solve this equation, and it will be then the final equation, the answer will be here. It will be 4.568. so that is the pH. Okay, this is the pH of a solution. So that means this buffer solution of the acetic acid and the salt will have a pH of 4.568. What volume of the 0.1 molar sodium formate solution should be added to the 50 ml of the 0.05 molar formic acid to produce a buffer solution of a pH 4? And the pKa value of the formic acid is 3.8. So we actually have a mixture of the acetic acid, formic acid, and the salt of the formic acid, right? So we have here a mixture of the formic acid, HCOH, formic acid, and we have how much? We have 50 ml of the formic acid. See, the 50 ml of the formic acid, and the concentration of the formic acid is 0.05 molar, right? The question is how many mLs of the sodium formate. Okay, we have to add a sodium formate we have to add a sodium formate HCOONA. The question is how many mLs. Let's say this is the X mLs. We're gonna add X mLs of the sodium formate in the 50 mLs of the 0.05 molar solution. And what is the concentration? The sodium formate concentration is 0.1 molar. So the question is, we have to find out the volume, right? How many mLs of this one we have to mix here so that you get a buffer solution of the pH 4. So we know that this pH as per the Henderson equation is actually pKa value plus the log of the concentration of the salt here divided by the concentration of the acid. Now let's first work on this area here, this ratio here, the salt by the acid ratio. Okay, we know the concentration is equal to the N by V, the number of the moles divided by the volume. So the number of the moles will be equal to the concentration into the volume here. Okay, for the formic acid is, we have concentration 0.05 into the volume is 50 mLs, which is 50 by 1000, right? You can see 50 by 1000, that is the volume here. And the formic, the sodium formate, the number of the moles will be 0.1 times, you can see the X by 1000. Okay, that is the volume. X by 1000 is the volume. So that means the concentration of the salt here by the acid will be, the salt here is 0.1 into X by 1000 and the acid is 0.05 into 50 by 1000, right? And this will be equal to, when you simplify this one, it will be 0.10 into x divided by this one will be 2.5, and this will be equal to 0.1 divided by 2.5 is 0.04x. So let's put the same value over here in this equation. The pH is 4, we know the pH is 4.0, so then it will be equal to pK value is 3.8 plus the log of the concentration of the 0.04x here. And when you simplify further, when you find the x value here, it will be 39.6 ml. So which means that you have to mix actually the 39.6 ml of the 0.1 molar sodium formate in a mixture, with the 50 ml of the 0.05 molar formic acid, so that you get a buffer solution of the pH 4. Right? Hope you got it. Thanks for watching the video. Bye for now.